Welcome to our CAD programming workshop. This video is presumably the last lesson related to configuration and setup issues around OpenCascade, and the idea of our today's lesson is to make the configuration process more automatic and more lazy, so to speak, because we do not really want to spend a great deal of time configuring all those linker options, include directories, runtime paths, and for example, this is not a really sustainable approach as what we did before, because for example, what if we change our working folder for third parties, or even switch our operating system to something like Linux, or even staying on Windows? What will happen if you want to upgrade our Visual Studio to a newer version of it with a different toolchain? And likely in all those cases what we'll have to do is to reconfigure all our projects, and this will be a tedious manual process, and we will have to do it again and again and again. So our plan for today is to get started with another and just simply better configuration approach, which is CMake. And CMake is a cross-platform open source software which is being developed by Quaoar, and it's the same Quaoar which is doing VTK. So CMake itself is not a build system, it's rather a system to generate build files for IDEs for other build systems like Make or Visual Studio and all those things. And for us, these files would be Visual Studio projects and solutions, while on Linux it might be just Make files, for example. So our plan for today is to prepare a main CMake list for our exercise, which we've been doing during the previous lesson, the exercise which was related, if you remember, to visualization in OpenCascade, and then we will also briefly discuss some useful features of CMake which you could benefit from. To start off, I just switched to the directory with my lesson containing this main function and viewer from the previous lesson, and I created an empty file which is cmakelist.txt, and I also removed everything related to Visual Studio, like I delete all the files for solution and project files of Visual Studio. So now I can start from sort of blank sheet speaking about configuration. And then for programming in CMake, because CMake is sort of programming language, so to speak, I'm going to use Visual Studio Code, because Visual Studio Code can be enriched with sort of extension specifically for CMake, so that you could highlight all the CMake instructions over here. So you see that when I move my mouse pointer over this CMake minimum required instruction, I see the hint here. And if you do not see it, when you go to extension, here you can type something like CMake. Actually, I just installed the first thing which appeared in this list, and I do not think that you need something more advanced, because CMake itself is not like a rocket science anyways. So let's try to have something here, and as you see already now, I have this CMake minimum required version 3.0. Actually, it's a quite old version already, but this version of CMake already supports most of the features which we would like to have in a typical project being configured with CMake. So the first thing you do basically when you start working with CMake is you go like project and you give your project a name. So for my lesson here, I'm going to give it a name like lesson 04, and it's going to be a C++ project, so that I type here CXX. So basically here we already have like a workable script. So let's try to configure our project and to generate basically Visual Studio project and solution based on this small cmakelist.txt. And you see that I am running CMake 3.19.1, and here I need to do a couple of things. As usual, I have to specify this source folder, which is a folder which basically contains this CMake list.txt, and then I have also to specify this binaries directory, which is going to contain the generated Visual Studio solution and project. So in my case, why not just to make a subdirectory like build. And here we go, we can click configure. CMake will ask if you want it to create a directory for us, so why not? Let's do so. And then the important stage here is to select this generator. In my case, it's Visual Studio 2019, and then make sure to select here x64, because why would you develop anything for 32-bit platform? So then we click finish. You see that all these variables are sort of in red. It basically means nothing but these variables got some changes, so that if I just click configure again, then you see that it's all fine here. So now I can click this generate, and actually I can now proceed with this open project button. And you see here is our empty solution because it doesn't contain any sources. What it contains is a set of predefined CMake projects. One is all build thingy, which is simply purpose to compile everything we have in our solution, and another is zero check, which is a project to rerun CMake in case if we have any changes in our CMake script. So that's not very useful. So let's close it for now and proceed with developing our project. So basically what we have an executable project because we have this entry point as a main function, and that's why we are going to add executable in CMake. And we give it a name, which in my case is going to be just the name of the project. And then I have to specify here all the source files I want to include in my project. If I switch back to my working directory, I can just take all those file names from here and paste it all here. So let's try to repeat our experiment. I will reconfigure this project by hitting this configure button again, then generate an open project, and we'll see what is the difference right now. You see that there is this project now, which is lesson 04, and if I go there, if I open its properties, I see that it's sort of application because I added it as an executable. Basically, as you would expect, there is nothing related to OpenCascade so far. If I go to C++ general, I will not see any include directories over here pointing to my OpenCascade. The same applies to linker. I have nothing about OpenCascade and linker options. But the good point about this configuration with CMake is that I do not have any redundant, so to say, platforms, because if I open this combo box here, I do not see this 32 configuration. And what I have for configuration here is debug. Then you see that there are quite some other options like min size, release with debugging info, and release itself. So this is sort of predefined settings in CMake when I run it for Windows, when I run it for Visual Studio Generator. But let's close it for now and switch to the contents of our project. And you see that there are like two filters which were automatically generated by CMake for our solution. One of them is header files, it contains all the H files we have, and another filter is source files. And here we have our main function and also this viewer and viewer interactor, all those familiar things. It's not surprising if you try to compile this whole project, it will simply not compile, because you see that this includes directives they could not be resolved by Visual Studio, and this is something we are going to fix right away. So let's close this solution again. And basically now I'm going to make CMake aware of OpenCascade, and for that, if you want to wire in any third party in your project using CMake, you will most of the time use this find package instruction. And here it's going to be OpenCascade. And let's see what will happen if I keep it like this. You see that now configuration is not successful because CMake tries to find OpenCascade somewhere on the system, and it simply could not do this because it has no idea where I have my OpenCascade installation. So basically we need to fix the value of this OpenCascade dir variable. Let's do this. So I will point CMake to my version of OpenCascade which I've built before, which is OpenCascade with samples no matter what, and then you go to the installation folder of OpenCascade, and here you need to select the CMake folder. Once you are done, you can configure it again, and you see now it's better. Now we do not have any complaints from CMake or from whatever, so let's generate and let's open our solution again. And you see that according to IntelliSense it's still not working because I still have to do a bit of configuration in my project. So let's close it again. And what is basically missing here is two things. One thing is include directories. CMake would not try to modify your include directories simply because you asked it to find a package. Okay, package is found, it means that some internal variables were initialized, but you still have to do a bit of configuration yourself. And to do so, we go like include directories. Then again, okay, here we do not need to specify our project name. What we have to specify is like to have the system here, OpenCascade, include dir, like this. Let's repeat our configuration and then go back to Visual Studio. Each time I open Visual Studio, I am basically working with a different updated version of Visual Studio solution and project file, because it's basically been completely rewritten on the file system. So if I go now to lesson 04 and to C++, here in general, you see that I now have these include directories. And the good point about this is that I haven't specified any absolute paths to OpenCascade except for this OpenCascade dir here in CMake. So it basically means that this CMake.txt file is machine independent, and you can put it in your repository and it will be working nice for you and for your teammates and for other external people. So now I can try to compile it, and before I try to compile it, basically I want also to show you that if I switch configuration to something else, like to release, I still have these include directories over here. So let's try to build this project, and now I should have some linker errors. Yeah, we've got them because actually we still have to configure our linker as well as compiler. So let's proceed with our CMake configuration, and basically one thing to keep in mind is that this executable, this target which you have added as executable or as a library, because you could also have something like add library in CMake, this target starts to be available only after the corresponding invocation of add executable or add library. So when you configure linker, you have to do it after you added your target. So we are going to configure our linker here. And basically to do so, we need to use this target link libraries instruction of CMake when we specify this project name, which we have after we added this executable. And then we also have to precise the configuration I'm configuring right now. So it can be debug or it can be release. And now I need to add here this OpenCascade library. And basically to do so, you need to add not just one library, you need to add many of them. And you can choose to have all the relevant libraries somewhere as a list. You can create like a CMake variable over here and then to use the elements of this list to configure your linker, or you can also simplify things if you just add all the libraries of OpenCascade. And I'm going to do this. I'm going just to iterate using this for each instruction of CMake. I will have this leap as my current iterator, and I have no idea why it's being added also here in end for each, because here we need just to have like empty braces. And here I am going to take advantage of predefined CMake variable coming with OpenCascade, which is OpenCascade libraries. So basically, if you are curious, how do I know this, how do I know the name of this variable, I can give you a hint. You can switch back to your folder with OpenCascade, then you go to your installation directory and to CMake, and you see that there are many CMake related things over here. So I'm just going to open this OpenCascade config.cmake, and here I will find all those variables which I'm using actually. So when I was preparing for our today's lesson, I just skimmed over this file and just found the variables which can be useful for configuration, like this one for example. And you can also notice that there is also a version of OpenCascade which is a 7.6.0, then development version, so you can use a lot of these things in your configuration environment. And you can see also that if you want to plug just a specific module of OpenCascade, like only modeling for example, you can use these OpenCascade modeling algorithm libraries with modeling data and foundation classes. So you are not obliged to include all the libraries in your project. But let's simplify things and just add everything. So here in this loop body I am going to use this target link libraries, and here I specify this lesson 04, then debug, and then this OpenCascade library dir. And basically here, because I am iterating over the list, I am also going to pass here this leap thingy. But I'm not quite sure what I'm doing correctly, because I'm not sure about the contents, about the value of this variable, and also the same way I'm not sure about the contents of this variable. So let's try to print it, let's try to double check ourselves, and to do so we can use another instruction of CMake, which is message, then status, because it's not going to be something like error or warning message, it's something for diagnostic. And let's put here this variable value like this, and we also give it like a name to be easily distinguishable. And also I'm going to print this leap variable as well. Here we go. And for the moment I will comment this thingy out. So let's try to repeat our configuration. And you see that what do we have here in the loop? Okay, I printed this as many times as many libraries I have, but it's a sort of stupid thing. But okay, let's forget about it. And then we have this leap, which you see it points to the base file name of the library. It doesn't point to the full file name or anything. And also another thing to notice here is that this leap doesn't contain suffix for debug, because if you remember, when we install OpenCascade in debug, we have not leap but leapd. So this is also something to take into account. So let's do this. I will erase these status messages over here, and I will continue with my target link libraries. So here I have this OpenCascade library dir, and since I'm configuring these linker options for debug, I can put d here. And also I need to add something like leap. And then I repeat this statement for release. But this time I'm going to erase, I'm going to get rid of this d suffix, because it's not going to be there anymore. So we are basically done with that. Let's try to configure this project again. I open it in Visual Studio once again. And let's go to the project properties. And here you see that in linker options, in the input, we have something strange. Did I make like a mistake somewhere? Ah, yeah, of course. In CMake it's not going to be released, it's going to be optimized. Yeah, here's a problem, because I noticed that there is this stupid release.leap, which doesn't exist simply, so this is something to be fixed. Let me reconfigure this whole thing. Oh, actually I can show you another thing. I can show you how this zero check works. If I keep my old solution as it was before, I can go to properties again, and as you can see here we still have this release.leap. Since I modified this CMake.txt, it now has got an updated modification time, and if I build this zero check project, what is going to happen? It's going to rerun CMake automatically, and you see that in the output there is this configuring done and generating done, all those familiar diagnostic prints. So now my solution was updated, and Visual Studio claims that there is something updated, and that's why I have to reload. And I basically am going to reload all the things. And if I go back to my linker options over here, you see that there is no this strange library anymore. And if I open it while being in the release configuration mode, you see that I have like a correct path. I have this leap folder here, and this seems to be just fine. And if I switch to debug, then you see that now it's leapd in all of the cases. So I can now compile this lesson, and it's going to compile without any problems. But what I cannot do, I cannot run it, because there is still missing runtime. So we are almost done with our exercise, we are almost done with configuration using CMake, but there is one thing we could not do right now. There is this missing runtime environment, and actually if I just like go and set this project as a startup project, it will not run, because Visual Studio is not able to find all those dynamically linked libraries, and that's clearly a problem. But actually you can solve it. You can solve it with CMake as well. CMake tends to be very general in terms of how many IDEs it supports, but there are also some properties which you can configure specifically for your IDE of choice. And you can do some specific configuration for Visual Studio as well. So I'm going to show you how you can do this, how you can specify this path variable. But let me just copy and paste the corresponding piece of code from the repository which I prepared for you, because actually this configuration line which we are going to insert into our script is not very obvious thing, is not very easy to type it, to say so. So let me go to this lesson 4, and if I go to this CMake list, this is a sort of solution I would propose you also to take a look at. we can find this set property here. So you see here it's a target, it's a lesson 04 again, but now we are going to specify a property which is Visual Studio Debugger environment, and here we go. Here we specify all those OpenCascade binary directories which we need for the runtime. So I am just copying and pasting this line into my script somewhere here, for example. So now you can build this zero check project once again to take advantage of all the changes you've done in CMake list.txt, but actually I would advise you at this point that whenever you modify something related to runtime environment, whenever you modify some Visual Studio specific environment of some IDE specific environment, you'd better go and delete your build directory, because otherwise some changes might not take effect. So I'm going to close Visual Studio for now, and I'm switching back to my CMake, and here I go like file, delete cache, let's do like this, and then I also go to remove my build directory from here, and I'm going just to repeat this exercise of configuration. Basically, it might be not necessary to remove the cache. You can keep the cache, but remove the build directory so that you will not have to configure this whole set of variables again, and it will save you some effort. Alright, so I'm ready to go. I have this reconfigured project. Now I can switch this project to be like a startup project, and basically it's also possible to do this with CMake because there is a corresponding Visual Studio property you can take advantage of. So now I'm going to build this whole lesson again, and finally I run it. Here we go, we have our exercise up and running, and actually when you are going to commit your changes, when you are going to make a delivery of your project, let's say so, you will not have to commit, you will not have to upload to repository any IDE specific files like Visual Studio Solution or project files, because now you have this clean and simple and easy to read CMake script, which does a great job of configuration. Because here, let me draw your attention again to that fact that here we do not have any absolute paths actually. So we have everything to generate our IDE specific project, but we do not have those projects themselves, and actually that's a big deal.